Hey everyone, welcome back to Science by Asha Matpal. In my last session, I have already started with the class 10th chapter Chemical Reaction and Equation, and I have explained till the topic chemical equation and how to balance them. In today's session, I will be starting up with the types of chemical reaction. So let's move ahead in the chapter. So the types of chemical reactions, basically these reactions are characterized or they are differentiated from each other on the way they are occurring. Okay, how the chemical reaction or the chemical change is observed, on that basis we have made different types of the chemical reactions. So the most common one is the combination reaction, then we are also having decomposition reaction, then displacement reaction, then double displacement reaction, precipitation reaction, that is a reaction in which a precipitate is formed or a curdling kind of deposition is observed. Those are called as the precipitation reactions. Then neutralization reaction, and then we are having reduction oxidation reaction. In short, they are called as redox reactions. Okay, so we will be understanding these reactions one by one. So let's move ahead. Now we'll start up with the combination reaction first of all. So the combination reaction, if you see the word, it is having the word combination to it. That is, combination means combining. Okay, the literal meaning of this word is combining. For example, if A is getting combined with B, you will be getting AB. Okay, this is a simple combination example where A is getting combined and a product is formed, that is AB. Now here this side, A plus B is obviously reactant side. Okay, so A is a reactant and B is also a reactant. They both are getting combined together and they are forming the product AB. So AB is what here? AB is the product, right? Now if this kind of pattern we are observing in a chemical reaction, or if we are seeing any chemical reaction where there is reactant which are two or more than two and they are forming a product together, then those are called as the combination reactions. Now I'll give you example. For example, H2 plus Cl2. Okay, when H2 combines with Cl2, and in my previous session I have told you that how to make a chemical reaction more informative. So here Cl2 is a gas, you can write next to it a gas, and H2 is also a gas, and they are forming HCl together. Okay, now this chemical reaction is not balanced, but it is an example of a combination reaction. Here you are seeing H2 is getting combined with Cl2 and it is forming a product. So H2 is getting combined, it is getting joined or combined to form a product, okay, which is a compound here. Now how to balance it? If you see reactant side, H2 and Cl2. On the product side it is HCl, so simply put 2 in front of HCl. So this 2 will go to H also, this 2 belongs to Cl also. So now H is also 2, Cl is also 2 in the reactant side, and if you in the product side, and if you see in the reactant side, again H is 2 and Cl2 is 2. So this is an example of a combination reaction, a very simple example of it. Now if you will observe this equation, H2 is an element, right, and Cl2 is also an element. Okay, and this is a compound. So in a combination reaction we can see an element getting combined with an element here. Okay, let us take another example. This example is very much common part of our everyday life. Okay, for example, if we take quicklime is CaO, okay, and it is in the solid state. It is called as the quicklime. Its common name is quicklime, although its chemical name is calcium oxide. See, this is calcium oxide. Now how we are writing its formula? Calcium oxide, see, calcium valency is 2, oxygen valency is 2. Okay, so this 2 will go to Ca, this 2 will go to O. So when valencies are same in number or they are 1, they are never shown, so the compound will be CaO. Okay, so calcium oxide formula is CaO. It is in the solid state. We are writing small s here. Okay, when it gets mixed with water, H2O, okay, in the liquid state, it forms slake lime, CaOH whole twice. It is soluble in the water, that is this whole thing CaOH2. Okay, so this is called as calcium. Ca stands for calcium, OH is hydroxide. Okay, so calcium hydroxide formula also, see, Ca and OH, right? Ca is the symbol of calcium, OH is the symbol of hydroxide. Calcium valency is 2 and OH valency is 1. Okay, so this 1 will go to Ca, this 2 will go to OH. So now Ca1 and OH whole twice 2. Why we are putting this bracket? Because this bracket is telling us that OH is together. Okay, so OH whole twice. So CaOH whole twice, we are writing the formula here. 1 is never shown, so we just ignore it simply. So it is CaOH whole twice and it is in aqueous state. Now the common name of calcium hydroxide is slaked lime. Is slaked lime. This is its common name. CaO is also called as the quicklime and its scientific name is calcium oxide. So now see here, CaO is a compound and H2O is a compound. So we are seeing combination reaction between a compound and a compound also. Right. Now another thing in this chemical reaction is this, that when we are mixing CaO in water, for example, when we are putting CaO inside a beaker or a container which is having water, and when we mix it, after that, if you will touch the walls of the container, you will find that the walls of the container are a little bit warm. Okay, suppose this is the container. Okay, in this you are having water. Okay, and in this you have added CaO. Okay, so CaO plus H2O, you mix it and then you touch the walls of the container. If you will touch the walls of the container, you will find that it is warm. The walls are a little bit warm. Okay, so it tells us what? That it is an exothermic reaction. That is, the heat gets evolved. It comes out in this reaction. So it is an example of exothermic reaction. Exo means outer, that coming out. So this is an example of an exothermic reaction also. Okay, so heat gets evolved in this reaction. Now this calcium hydroxide or the slake lime which is formed, it is then applied on the walls. Okay, this CaOH whole twice, when get applied over to the walls, it is used for the whitewashing purpose. So what happens, that when it is applied on the walls, it combines with the carbon dioxide gas of the air. Okay, and when it combines with the carbon dioxide which is present in the air, it forms a compound that is CaCO3. Okay, that is calcium carbonate, and water gets evaporated slowly. Okay, so after 2 to 3 days we get a shining white wall. Okay, this shining white wall is due to the formation of the CaCO3, that is the calcium carbonate. Okay, so meaning to say that combination reactions are basically simple reactions in which reactants which are 2 or more get combined together and they form a single product. Okay, so the combination reaction can take place between an element and element, between a compound and a compound, and between an element and compound also. I will give you example after some time. Let us recap this one first. So first one is element and element getting combined. So here we have understood that H2 gets combined with Cl2 and it forms HCl. Okay, another we have understood between compound and this reaction is very much important also in terms of the examination point of view. Here you are seeing that there is calcium oxide. Okay, the most common name of calcium oxide is quicklime. Okay, during the whitewashing of the walls, the calcium oxide is mixed with the water. Okay, and if you will touch the walls of the container in which you are mixing, the walls appears to be a little bit warm because it is an exothermic reaction and this mixing evolves heat. Okay, the product formed is calcium hydroxide. This calcium hydroxide, which is also called as the slake lime, is then applied on the walls. Okay, and this is called as a whitewashing. So when it is applied, then it is left for 2 to 3 days, and in between those 2 to 3 days, this calcium hydroxide combines with the carbon dioxide present in the air and forms calcium carbonate. Okay, so there is a layer of the calcium carbonate which gets deposited over to the walls between the 2 to 3 days, and this is how we say that the walls are getting whitewashed. Okay, so combination reactions are very much simple. It can take place between an element and element. It can take place between a compound and a compound, and then it can take place between an element and a compound also. Okay, so I'll show you another reaction for that. Okay, so this one I have told you a very common one. H2 plus Cl2 gives you, sorry, here 2HCl. Then here we have taken example of quicklime and water. Okay, you can write any reaction. This reaction is very much important in terms of examination point of view. That is why I am telling. Okay, and here it is aqueous. Element and a compound, you can form CO plus O2. Okay, gives you CO2. Okay, so this is also an example of an element and a compound reaction basically here. So if you see the definition which I have mentioned here, two reactions in which two or more elements or compound combine together to form a single compound are called as the combination reactions, and they can take place between two elements, between two compounds, an element and a compound. Now if you want to balance it, this side we are seeing oxygen is 3 in the reactant side and the carbon is 1. So here carbon is 1 but oxygen is 2. Okay, so how you're going to balance it? In front of this you just write 2. I have always told you that start with a simple multiple of the 2. So let us start with the 2. So this 2 will go to C also carbon. Here it is 1, so we can write 2 here. So here carbon becomes 2, but by putting 2, this 2 is going to oxygen also. So 2 oxygen here plus 2 here, 4. So in the reactant side we are having 4 oxygen, and here also 2 into 2, 4. So this is the balanced equation for this one. Okay, element is here O2. Okay, compound is here CO, and it is forming CO2. Right, so these are some very common examples, okay, which we see generally. So this is how a combination reaction takes place. Now let us start with the second type of chemical reaction, which is a decomposition reaction. Now as the word is suggesting here, decomposition means breaking. The word decomposition means breaking simply. Right, so these are the reaction in which the compounds gets broken down, okay, and then it forms the product. So in the decomposition reaction, what we see, let us say that there is a compound AB, okay, it gets broken down into A plus B. So this is a standard or a very simple way of understanding a decomposition reaction. So AB is what? It is a reactant. Now all of a sudden or on its own, the compound will not get broken down. So it needs some kind of you can say push. So this push, that it is taking place always in the presence of the heat. Either we will have to supply heat to the reactant, or we can supply electricity, right, or we can give light, that is the sunlight here, you can say. In presence of any of these agents, the reactant can be broken down. Okay, the reactant can be broken down, and then it can give us two or more product. So this is how a decomposition reaction takes place. Remember, in all the decomposition reaction, we are supplying the energy either in the form of the heat, okay, or electricity or sunlight. So we are giving energy in decomposition reaction, or after giving energy only, the reactant gets decomposed or broken down. So these are endothermic reaction. These are endothermic reactions. Okay, that is, they absorb energy and then it occurs. So they are called as endothermic reaction. Energy either in the form of the heat, sunlight or electricity, they are absorbing and then they are getting decomposed or broken down, right? So here we can see that a combination reaction is different as compared to a decomposition reaction. In the combination reaction, the reactant are two or more. Here in the decomposition, reactant is one only. Okay, in the combination reaction, heat gets evolved. Here heat gets absorbed in the decomposition reaction. So let us try to understand more about a decomposition reaction. Okay, there are various other categories inside it also. So this is a general definition for it, that reactions in which single compound breaks down to give two or more simpler substances, they are called as the decomposition reaction. The decomposition reaction takes place only when the energy is given in the form of the heat, electricity or light. They are of three different types, okay, on the basis of what kind of energy you are giving. The one is called as thermal decomposition, that is where you are applying heat, okay, that is after giving heat only the reactant is getting broken down. Then we are having electrolytic decomposition, that after supplying electricity or giving electricity, the reactant is getting broken down into the product. Then we are having photo decomposition or photolysis, means light, that is basically we are talking here about the sunlight, okay, or light as a form of energy. So after giving the light, the reactant is getting broken down into the product. So decomposition reaction are of three types. So let us try to understand them one by one. So first one is the decomposition reaction. Example is the thermal decomposition reaction, which we are discussing here. Thermal decomposition reaction. Okay, now this is a reaction in which we are supplying heat to the reactant, remember, that is why the word is thermal. Now there is a very popular reaction, that is when lead nitrate is heated. Okay, when the lead nitrate is heated, that is here, this is in the solid state and it is white in color, and this is the symbol of the heat. So it gives us lead, okay, it gives us the lead oxide here, nitrogen oxide, and oxygen. Okay, so it gives us the lead nitrate gets broken down into the lead oxide, nitrogen oxide and oxygen. Now how we are going to write it? See, lead nitrate, nitrate symbol is NO3, okay, and lead symbol is Pb. Okay, now the valency of Pb is 2 and nitrate is 1. So this 1 will go to Pb and this 2 will go to NO3. Now it will be Pb, NO3 is together, so you will be putting a bracket and at the foot you will be writing the valency of its neighbor. So it will become PbNO3 twice, whole twice. So you just write PbNO3 whole twice, arrow, and this is the heat symbol. Now here we are having the lead oxide as a symbol. So lead is Pb and oxide is O. So Pb valency is 2, oxygen valency is also 2, so it will go to its neighbor, so it will become PbO, because when valencies are same or or it is 1, they are never shown. So this is the lead oxide. It is in the solid state. You can mention the solid state here also. And then nitrogen oxide is NO2 and this is O2, right? Now the PbNO3 whole twice, which is white in color, when it is given heat or when it is heated, it gives us the lead oxide, okay, which is yellow in color, and there are brown fumes of the nitrogen oxide. Now in the lab, how we are conducting it, we take a test tube. Inside the test tube we put the lead nitrate, okay, and we take this test tube over to the burner. We hold the test tube with the help of the tongue and we just give it heat, okay. So when you will start giving heat to it, you will observe that the brown fumes will start coming out. So these brown fumes are indicating that the nitrogen dioxide is getting formed here, okay, and you will see that a residue which is yellow in color will get deposited or will be at the base of the test tube, and this is of the lead oxide. So here this is nitrogen oxide I have written, you can write it as dioxide, okay. So the symbol is correct, NO2 here. So this is a change which we are observing when we are heating the lead nitrate over to the heat. So we are giving heat to the lead nitrate, and after absorbing this heat only, the lead nitrate is getting broken down, okay. So we are supplying the heat energy and then only this reaction is occurring. So this is called as thermal decomposition reaction, okay. And we observe the change that it changes from white color to the yellow color. Now how you are going to balance this whole equation? Now see here, Pb, it is 1 here and N is 2. This 2 belongs to N also, so N is 2 here, and O is 6. 3 into 2, 3 2s are 6, okay. So O is 6. Now count the O here, it is 2 here, it is 2 here, 4, and 1 is here, so it is 5. So in the multiple of the 2, you will be never getting the number 5. So what you can do, that you can put 2 here and then you can see 2 and 2 4, and here by putting 2, this oxygen will also become 2. So there are 6 oxygen in the product side now. Here also in the reactant side, the oxygen are 6 in number, and this N is 2 here, okay, remember, and this Pb is also 2. So what we can do, that we can put another if we are going to put another 2 here, okay, so it will change it to, just a minute, if we are going to put 2 here, so N will become 2 here, and here also it becomes 2, but oxygen will become 2 to 4, 4 and 2 6, and then here it will become 8, okay. Now here we are seeing that Pb is 1, here the Pb is 2, so we can put 2 here. So what will happen, Pb will be 2 here, N will be 4, and this one 6 2s are 12, so 4 8 and 12 here. So what we can do, that it is 4, N is 2, N is 4 here on this side, so if we put 4 here, so N will become 4, oxygen will become 8, 4 into 2 8, and 2 here 10 and 2 here 11 12. So in this way the equation gets balanced. So basically decomposition reactions are the ones in which the reactant gets broken down. Now to break this reactant you will have to supply energy either in the form of the heat, electricity or light, right? So now we have understood the first type, that is the thermal decomposition reaction, and we have understood with the help of the lead nitrate reaction. Okay, when we heat lead nitrate, the white color lead nitrate changes into the yellow color and we see the fumes of the nitrogen dioxide coming out of it. Okay, and then we have tried to write its equation and then balancing it. Remember that if the equation is written correctly you will be able to balance it. Okay, now let us move ahead to the next type of the decomposition reaction. The next decomposition reaction is by supplying electricity. This is a very common example of it, and like in the exams also a lot of questions are asked from this topic. So second type of the thermal decomposition reaction is electrolysis. That is, by supplying electricity we are breaking the reactant. Okay, so here reactant is water. Okay, so we will break the water by supplying electricity. Now for this experiment a lot of children also do in the school, or the teacher makes them observe also. So what you will have to do, that you will have to take a container or a mug kind of container, cut the base, or you can say that make 2 holes at the base of it and just pass the carbon rods from these holes. Okay, they will act as the electrodes here. Okay, now you will have to connect these electrodes to a battery. Okay, generally we take a 6-volt battery here. So battery will have a negative end and a positive end. So connect one electrode to the positive one, another one to the negative one. The one which is attached to the negative one is called as the cathode, it is mentioned here. Okay, and the one which is attached to the positive side is called as the anode. Okay, now you can fill the container, okay, like up to the half or just above these rods you can say, and to this water we will add the sulfuric acid. H2SO4 is added. Why? Because the H2SO4 make it a good conductor, make the water good conductor of electricity. It make it acidic in nature, and acids are good conductor of electricity. Okay, then you can do what? You can take 2 test tube. Generally we take the graduated test tubes which are having some marking on them, and we fill them with the water. Fill the test tube with the water, like here I'll draw one. Okay, fill it with the water and invert it over to the electrode. Okay, similarly do for the another one also, just invert it over to the another electrode. Okay, and then you will have to start, that is on this battery, and observe. After some time you will start observing gas inside both the test tubes, and the level of the water will start falling and bubbles will getting formed. Let the bubbles get formed, okay, till the time you are able to observe them clearly. Okay, after that switch it off. What you are going to observe is this, that a lot of bubbles are formed, and there is one side, or there is one test tube in which the bubble formed are more as compared to the other one, and if you will try to count them, you will find that in one side it is double as compared to the other side. Okay, now see what was there inside the container. Inside the container there was water, okay, in which you have added the sulfuric acid to make it acidified for the good conduction of electricity. Now when electricity was passed, this water got broken down. Here you can write electricity over to the arrow. It got decomposed into the hydrogen and oxygen. Okay, the 2 elements from which it is made. Okay, so there is a formation of H2 also, there is a formation of O2 also inside the container or the beaker or the mug. Okay, now H2 is a positive ion. H2 is a positive ion and O2 is a negative ion, remember. Okay, if you see their valency also, O always gain and H always loses, so it acquires a positive charge and O acquires a negative charge. Now opposite charges attracts, so O is having the negative charge to it and H is having the positive charge to it. Okay, so this negative charge will go to the positive side of the battery, that is to this electrode. So here the oxygen is there and H is having the positive charge to it, so it will go to the negative electrode, which is the electrode connected to the negative side of the battery. Okay, right. So H2 will get collected over to the cathode side and O2 will get connected to the anode side. Now if you observe the bubbles are always more on the hydrogen. Okay, that is they are always in 2:1 ratio by volume. Okay, simply you can see that H2 is there, that is it is more than the oxygen. So what happens in the electrolysis of water is this, that this acidified H2O, you can write it at the bottom of it, okay, to make the reaction more informative. Okay, and when electricity is passed, it gives you H2 plus O2. Now you can balance this equation. Here H is 2, here H is 2, but O is 1 here and it is 2 here. You can put 2 in front of the O here, so it will become 2, but by putting this 2, H will become 4. 2 into 2 is 4, so you can put simply 2 here, so H will become 4 here and O will be 2 here. So in this way it is balanced. Okay, so this is about the electrolysis of water. Remember, on the hydrogen side the bubbles are double in number as compared to the oxygen side. Another thing, how you can further prove that the gas collected inside the side is hydrogen and over to the anode it is oxygen. For the oxygen you can do what, that you can bring a burning candle near to the mouth of the test tube. You will have to take it out, okay, by putting your thumb over to the mouth of the test tube. You will have to take out the test tube so that little bit of oxygen should be there. So bring a burning candle near the mouth of the test tube and you will see that the flame of the candle, if this was the flame, the size of the flame will get increased because oxygen is a gas which supports burning. And if you will bring a burning matchstick or candle near to the mouth of the test tube which is collected from the cathode side, you will hear a pop sound and the flame will get extinguished, okay, indicating that this gas which is evolved is a hydrogen gas. Okay, so this is how we can further prove that the gases which are evolved are hydrogen and oxygen. Now moving to the next decomposition reaction, the third decomposition reaction is the photolysis. Okay, photolysis. Photo means light, that is a decomposition reaction which is taking place after supplying light or in the presence of the light simply. Okay, the most common example of the photolysis are the silver chloride and the silver bromide reactions. Okay, we can take them in both are in the solid state. Okay, Ag valency is 1 and the Cl valency is 1, so obviously they will go to their neighbors and it will become HCl, the compound. Similarly for Ag and Br, this is silver symbol, Br is the bromide symbol, valency is 1, this one will go to Ag, this one will go to Br, and then again it will be AgBr. So both are taken as like in the form of their salt, that is in the solid state. If you put them into a petri dish or in a watch glass or in a china dish, okay, in the presence of the sunlight, keep them for some time. The color of the AgCl is white and the AgBr color is yellow. Okay, so when they are kept in front of the sunlight for some time, you will be observing that they will get broken down into their respective elements. AgCl will change to Ag plus Cl, AgBr will change to Ag plus Br. The color of the Ag is gray here, and here also it is gray in color. Okay, so they will change their color. So this is a decomposition reaction, or the breaking down, which is taking place in the presence of the light or the sunlight. That is why it is called as the photolysis decomposition reaction. This reaction is a very important part of the black and white photography, because the photo film or the films are generally coated with these salts, the AgCl and the AgBr. So it is a very common example, or it is widely used in the white and black photography techniques. Okay, so basically in today's session we have understood the first two types of the reaction. Reactions are made on the basis of that how these chemical changes are occurring. So first chemical reaction we have understood is the combination reaction, and the second one is the decomposition reaction. In the combination also, I have told you that combination can take place between element and element. It can take place between compound and compound. It can take place between element and compound. The decomposition reactions are the reactions in which reactant gets broken down either in the presence of the heat, sunlight or light, or in the presence of the electricity. Okay, so basically these are the two first type of reaction which I have explained in this session to you. Before going, I would like to request you all to kindly subscribe to my channel and share its link among your friends and family. See you in my next session, where I will be explaining you further types of the chemical reaction, that is the displacement, double displacement and more. Thank you. Bye bye.